In the winter dark, above the Pacific, a telescope blinked, and in that brief mechanical eyelid of glass, something older than light revealed itself. At first, it seemed routine, another faint streak in the digital night, a whisper of rock and ice passing through the quiet corridors between stars. But as astronomers adjusted their instruments and the data resolved into motion, unease crept in. This was no ordinary traveler. The object, catalogued as 3I Atlas, had come from beyond the sun's dominion, from the frozen dark between galaxies. It carried the trajectory of exile, uncaptured, untamed, and ancient beyond reckoning. But what made it unforgettable was not its origin, it was what followed. Trailing behind 3I Atlas was a void, a moving absence, like a wound in the light. Stars dimmed as it passed, their brilliance devoured not by dust or distance, but by something that consumed without mass. Telescopes recorded it as a shadow, though that word betrayed the truth. It wasn't the absence of light, it was the presence of something that made light forget itself. Astronomers checked their optics, recalibrated sensors, argued in whispered disbelief. Yet the readings held. The shadow was real, and it was following. The cosmos, vast and cold, has always offered mysteries beyond reason, pulsars that blink with the precision of clocks, black holes that hum in gravitational song. But this was different. It was not the echo of collapse or the residue of a dying star. It was motion without matter, a geometry of darkness in pursuit of something it shouldn't know how to follow. In the first nights of observation, the tone in the control rooms shifted. Data logs became confessions. "It behaves like intent," one astronomer wrote in a private note. "It moves as if it knows the object it follows." That was the first fracture, not in the sky, but in human certainty. The universe had always been indifferent, yet here was an indifference that moved with purpose. The faint traveler and its companion shadow continued their glide across the black, beyond the thin halo of the sun's warmth. Instruments on Earth, on orbiting satellites, and aboard deep space probes all began to detect its signature, an anomaly in the photometric readings, a distortion in starlight as though space itself was being folded behind the object, like silk under an unseen hand. The phenomenon had no precedent, no equation. It was a darkness untethered from causality. Even the most rational minds felt an ancient chill. For centuries, humanity had looked to the stars and found comfort in order, in Newton's laws, in Einstein's curvature of spacetime, in Hawking's event horizons. Each mystery, no matter how strange, eventually found its equation, its cage of understanding. But 3I Atlas arrived like a rejection of that faith. It carried something that refused to be solved. In the coming months, the world's observatories would coordinate their efforts. Teams from Chile to Japan, from the Keck Observatory to the James Webb Space Telescope, would attempt to define the indefinable. Yet, before the data could be parsed, one truth stood bare. The cosmos had shown them a shape that could not exist as shadow without a source, pursuing a traveler that had never belonged to this solar system. For the first time in modern astronomy, the word impossible began to appear in published drafts not as metaphor, but as description. Some called it an optical illusion, others a calibration error. But the silence of light is harder to explain than its presence. Photons do not lie, and whatever followed 3I Atlas was erasing them. It would take months to gather enough data, years to frame the questions, perhaps centuries to glimpse the answers. Yet already, a quiet terror began to spread among those who had seen the early frames. Because behind 3I Atlas's arc across the night sky, there was something that moved in lockstep, something no instrument could measure, no theory could contain. The shadow was not cast. It was alive in motion. And somewhere between reason and awe, a whisper began to circulate among scientists, passed only in private conversations, late at night, when the data refused to sleep. What if the shadow wasn't following the object at all? What if it was leading it, calling it home through the dark? When the first images of 3I Atlas reached the data servers in April of 2023, they carried the trembling fingerprints of astonishment. At the Haleakala Observatory in Hawaii, the Atlas System Asteroid Terrestrial Impact Last Alert System had done what it was built to do: watch the sky for wanderers. The software had flagged a fast-moving point of light that refused to obey the familiar ellipses of solar orbit. Astronomers leaned in, expecting a comet, perhaps a rogue asteroid thrown from the Kuiper Belt. Instead, they found an interstellar nomad, only the third ever recorded after Oumuamua and 2 Borisov. Its path cut through the sun's gravitational reach like a blade through fog, steep and strange, too fast to belong to anything born here. The name came quickly: 3I for third interstellar, Atlas for the system that caught it. But in the sterile nomenclature of discovery, there was awe. Humanity had met another messenger from the unknown, a stone bearing the scars of alien suns. At first, it was pure wonder. Telescopes across continents pivoted toward its faint trajectory. Observatories tuned to infrared, optical, and radio frequencies gathered what they could before the visitor slipped away again into silence. The James Webb Space Telescope joined the pursuit, its instruments capturing spectra that hinted at frozen hydrocarbons, complex organics, and silicate dust echoes of worlds never mapped. Scientists compared its profile to that of Oumuamua, recalling how that first traveler had accelerated strangely, as if pushed by invisible hands. But 3I Atlas seemed calmer, its velocity consistent, its behavior obedient to known physics. Until the photographs came back. At first, it was only a flicker frames, showing faint inconsistencies in the background stars. One postdoc noticed it while calibrating exposure levels: a subtle dimming, a shifting gradient, like a shadow trailing the object through space. No one mentioned it aloud for fear of ridicule. Shadows require light to block, and the vacuum between stars is empty of such things. But as data accumulated from Chile, from the Canary Islands, from orbiting telescopes, the anomaly grew undeniable. In late May, a joint meeting of astronomers from NASA, ESA, and several university teams convened virtually to review the compiled data. Across time zones, tired faces illuminated by monitor glow stared at the same set of frames. Each one showed 3I Atlas, a faint dot in motion, and behind it, a darker blot, moving with perfect synchrony. It wasn't an artifact, not lens flare, not a processing error. The signature persisted across instruments, filters, and angles. It was not the fault of machines. It was the universe itself misbehaving. The question that followed was simple and unbearable. What could cast a shadow in space? They searched for analogues, cometary tails, clouds of ejected dust, even magnetic fields interacting with solar radiation, yet nothing fit. There was no particulate reflection, no thermal trace, no measurable emission. Whatever followed 3I Atlas did not scatter, glow, or absorb in any way that physics allowed. It was absence moving through presence, a hole traveling through the very medium of light. The object's path took it near the outer regions of Mars's orbit, and observatories on Earth's night side turned toward it in synchronized surveillance. Data poured in: thousands of images, terabytes of light curves, spectrographic readouts. The more they observed, the less they understood. The shadow shifted subtly, not as a solid mass would, but fluidly, like ink dispersing in invisible water. Sometimes it appeared closer, sometimes farther, but always aligned, as though bound to 3I Atlas by a law yet unwritten. One scientist at the European Southern Observatory remarked that it reminded him of gravitational lensing, the bending of light around massive bodies, predicted by Einstein and confirmed near black holes. But this was no black hole, no dense singularity. The object itself was small, no more than a few hundred meters across, its mass insignificant by cosmic standards. Yet behind it, light itself was faltering. As the discovery rippled outward through the community, secrecy tightened. Data was flagged, access restricted, and non-disclosure agreements quietly extended. The world at large knew only that another interstellar object had passed through the solar system. The deeper anomaly was confined to those few who stared too long into its digital shadow. For those who had, sleep became fragile. One of the lead analysts from the Subaru telescope project later admitted in a private journal, "It feels wrong. The readings move like something watching, not reacting to gravity, but to attention." Her words were dismissed as exhaustion, the product of long nights and relentless data streams. Yet, among her peers, many felt the same unspoken unease. It wasn't just that the universe had birthed something inexplicable. It was that it had noticed we were looking. And so began the quiet collaboration, the unrecorded coordination between institutions usually separated by politics and pride. The mystery demanded unity. Instruments from Hawaii, Chile, the Canary Islands, and the Hubble orbit combined their observations into a composite map of light distortion. Patterns began to emerge, subtle curvatures and faint ripples, as if space around 3I Atlas were vibrating in tune with a rhythm not of this world. The shadow wasn't simply dark, it was structured. It obeyed geometry. Something was shaping it. In that revelation lay both exhilaration and terror, because geometry implies intent, and in the cosmic silence, intent is the one thing science fears to find. For now, the story of discovery was official, unthreatening, a harmless interstellar object, observed and catalogued, destined to drift beyond sight. But beneath the quiet press releases and modest academic abstracts, a darker narrative had begun, a tale of light devoured, of structure without matter, and of an absence that seemed to follow not by chance, but by choice. The first to name it, the uninvited darkness, was a radio astronomer from Chile, half in jest, half in dread. The term caught on, whispered through encrypted messages and late-night calls between observatories. The phenomenon had already surpassed the boundaries of comfort. It was no longer a quirk in the data, but a cosmic companion. Wherever 3I Atlas went, the darkness followed. The Keck Observatory's deep field imagery revealed the shadow in exquisite, terrifying clarity. Not merely a blur or stain, but a definable absence, a moving wound upon the sky. It had no measurable albedo, no spectral fingerprint, no indication of particles. Yet its shape evolved subtly, as if sculpted by invisible currents. Some nights, it appeared stretched and diffuse. On others, condensed and sharp, edged, like a blade carved from nothingness. The object it followed, small, cold, rocky, was unremarkable, but its tail, its darkness, seemed alive. Even when the object passed through denser star fields, where light should have pierced and outlined it, the shadow absorbed everything, not reflected, not refracted, simply gone. Light that entered never came out again. The Hubble team proposed gravitational microlensing as a possible cause. But the data betrayed that theory. The curvature of light wasn't around the object, it was within the void itself, like a hollow gravitational well without mass. A paradox, a riddle, a cosmic smirk. In July, the James Webb Space Telescope began its spectral analysis. Webb's sensors, tuned to infrared sensitivity unmatched in history, tried to read thermal variation, heat emitted, reflected, or even scattered. There was none. The shadow was colder than cosmic background radiation, the faint afterglow of the Big Bang itself. That made it older than light could measure, as though it existed before the universe decided to ignite. And yet it moved. The public knew little beyond a few press releases announcing anomalous behavior in photometric data. The reality was stranger. Meetings were held in secret. NASA's Jet Propulsion Laboratory, ESA's Astrophysics Division, and private data teams from MIT and Caltech all participated. They debated the impossible, a structure that interacted with light and gravity without energy or mass. Every law of thermodynamics cried foul, a thing that wasn't a thing. When the Atacama Large Millimeter Array, ALMA, joined the effort, scanning in sub-millimeter wavelengths, the data deepened the unease. The shadow seemed to fluctuate, oscillating in synchronization with the object's spin period. Like a reflection, but from what it was, as though 3I Atlas were dragging behind it a distortion of itself, projected backward through time. The equations attempting to model it failed catastrophically. Energy outputs diverged to infinity, constants collapsed into zero. It's like trying to divide reality by itself, one physicist muttered after his simulation crashed. More unsettling still were the observations from Japan's Subaru telescope. A series of exposures taken hours apart showed the darkness altering its relationship to nearby starlight, pulsing faintly. This was no static phenomenon. It behaved as though breathing, and each breath seemed to sync, not with any stellar rhythm, but with the timing of the telescope's observation intervals, as though it knew when it was being watched. Speculation became superstition. In observatory cafeterias and message threads, scientists joked about the eye in the dark. But the humor thinned with each new anomaly. The shadow's photometric outline exhibited patterns reminiscent of fractal interference, self-repeating geometries, infinite in resolution, as if its edges were not boundaries but recursive infinities folded upon themselves. One cosmologist proposed it was a boundary effect between our spacetime and another. A shadow, he said, not on the ground, but between dimensions. Others were more cautious. They proposed unseen dust clouds, dark plasma, magneto-hydrodynamic anomalies, even interstellar fog dense enough to warp light. But each idea collapsed under scrutiny. The phenomenon moved too precisely, too intelligently. It obeyed the object's orbit, adjusted its velocity when the object shifted course, always maintaining perfect distance, as if tethered by an invisible thread. By late summer, 3I Atlas approached perihelion, the point nearest the Sunday. Astronomers anticipated that increased radiation would expose the object's composition and perhaps scatter the shadow. Yet, as solar wind bathed it in plasma and light, the void did not dissolve. Instead, it grew darker, deeper, almost solid. Solar rays bent inward, as though being drunk by an unseen mouth. The sun itself seemed to dim around it, a measurable reduction in local luminosity, subtle but real. The darkness was not fleeing the light, it was feeding on it. A collective unease spread through the astrophysical community. Many had seen black holes distort starlight, neutron stars twist gravity, quasars burn brighter than galaxies, but this was different. This was motion without matter, a predator of photons. And if such a thing could exist, it implied an unthinkable truth that the universe still harbored rules we had never met, physics that had watched us learn and remained silent. In one recorded discussion, a senior theorist at Princeton broke the quiet, "Perhaps it isn't following at all. Perhaps we are mistaking cause for consequence. What if 3I Atlas is the shadow's companion, not the other way around? The object may not be carrying the darkness may be carrying the object." The words hung heavy. They rewrote the relationship entirely. The shadow, in that view, was not an afterthought. It was the primary entity. The solid mass, the small interstellar rock, might simply be the seed around which it gathered, a bait, a kernel, a memory it dragged through space. For the first time, the question arose not of what the darkness was, but why it had come. If it was matterless, ancient, and cold beyond comprehension, what purpose could such an entity have in following a stone across infinity? Could it be a phenomenon of space-time itself, a reflection of cosmic history folding back, or something older than physics, a ghost of creation's first silence? Observations would continue, but for now, the name whispered in observatories across Earth was fixed. Not 3I Atlas, not its path or shape or spin, only that impossible absence, the uninvited darkness, crossing the sky, without reason and without end. When physics trembled, it did so quietly. Equations didn't shatter, they just stopped making sense. The first simulations that modeled the 3I Atlas anomaly began to produce absurdities, values that diverged into infinity, variables that refused to converge, constants that behaved like living things. The darkness behind the object wasn't a region of reduced luminosity, it was an inversion. The numbers suggested negative photonic flow light, vanishing not by obstruction but by subtraction, as if some unseen geometry were undoing the very act of illumination. The term that spread through the teams was photonic deficit, a poetic euphemism for something more terrifying light that, having entered a region of space, simply ceased to exist. Not absorbed, not scattered, erased. No particle interaction could account for that. Even antimatter obeyed the conservation of energy, returning its balance in radiation. This did not. In the realm of known physics, such behavior implied one of two impossible things, either a violation of thermodynamics or a hidden dimension siphoning energy elsewhere. When Einstein wrote of the curvature of spacetime, he described a universe of smooth, continuous fabric gravity as geometry, not force. But this was a tear, not a curve. The shadows region exhibited anomalies that suggested local spacetime contraction without the necessary mass. General relativity bowed, twisted, and fell silent. Quantum mechanics, with all its probabilistic elegance, fared no better. The uncertainty principle could not explain coordinated darkness. The wave function of photons, it seemed, collapsed before entering the zone as though reality itself refused to compute. At CERN, theoretical physicists ran gravitational field equations with simulated negative energy densities. The results matched disturbingly well. What followed 3I Atlas was not a shadow in the conventional sense, but an inverse field, a local pocket of negative spacetime curvature that mimicked gravitational pull without matter. It was, in essence, an anti-gravity imprint. The concept had existed only in speculative frameworks, Casimir effect extensions, wormhole models, and exotic matter discussions, but here it was, potentially real, gliding through the solar system. In that realization, awe turned to dread. Negative energy was not just rare, it was catastrophic. It implied that the universe, under certain configurations, could fold inward upon itself. And worse, it hinted that something could travel not through space, but through time, using space-time's negative curvature as a corridor. The shadow might not be a passive phenomenon at all, but a moving instability, an artifact of something bleeding into our reality from another continuum. Across the Atlantic, in a quiet meeting room at the European Space Agency, one astrophysicist whispered what others dared not. "It's not breaking physics, it's showing us the rest of it." Those words lingered like a haunting. Perhaps the universe had always been incomplete, its laws mere local approximations of a broader, darker symmetry. Still, the human mind resists the infinite. Science sought the measurable. So researchers began searching for precedent echoes of such phenomena in earlier cosmic records. They found fragments, unexplained dimming events in deep sky surveys, random drops in background radiation, anomalous lensing that couldn't be attributed to dark matter. The data had been dismissed as noise. Now, it looked like prophecy. The most disturbing anomaly came from the Kepler Space Telescope archives, a star catalogued as KIC 8462852, once famous for its irregular dimming. At the time, some had speculated alien megastructures, others dust clouds, but buried within the flux readings, one team now identified a pattern almost identical to the 3I Atlas shadow signature, a centuries-old whisper, repeated across light years. Could this be the same phenomenon, appearing again and again, tied not to objects but to motions through spacetime? One hypothesis emerged radical, elegant, and chilling. The shadow might be the visible consequence of spacetime repair, a cosmic feedback loop correcting tears caused by interstellar traversal. 3I Atlas, traveling faster than local gravitational equilibrium, might have dragged a defect in spacetime's lattice, creating a wake of negative curvature as reality struggled to heal behind it. The shadow would thus be the scar, the universe's attempt to close the wound. But if that were true, then something larger loomed. Because spacetime tears, once formed, did not remain small, they propagated, consuming everything within reach until the vacuum itself destabilized. The physics team at MIT's Kavli Institute ran energy density simulations for this scenario. They found a threshold. If the anomaly's expansion exceeded a certain radius, the resulting collapse would create a localized vacuum decay, a pocket universe, ruptured from ours. The probabilities were infinitesimal, yet not zero. An event like that, the report concluded, would rewrite the constants of nature. Inside it, light, gravity, even time would no longer behave as we understand them. The shadow, then, could be not merely an observer, but an omen, a herald of instability spreading through the fabric of reality. Yet there was another interpretation, more unsettling still. If the darkness fed on light, not as matter consumes energy but as information consumes data, then perhaps it was not destruction but recording. Perhaps it was memory, the universe's way of remembering what had passed through. Every photon absorbed could be a trace, a cosmic ledger of existence itself. One physicist in Geneva summarized it quietly: "It may not be death, it may be the archive." Still, the archive moved. It followed with precision, responding to no known force. And as the months passed, the instruments tracking 3I Atlas began to report subtle fluctuations in Earth's magnetosphere, tiny periodic ripples coinciding with the object's trajectory through the inner solar system. Coincidence, perhaps, or resonance? By the year's end, even the skeptics conceded that the phenomenon was no trick of light. The cosmos had introduced something new, something uninvited, that stood outside the diagrams of physics. The shadow did not destroy our understanding of the universe. It merely reminded us how small that understanding truly was. For the first time since Newton's apple, since Einstein's equations, since Hawking's paradoxes, humanity was forced to confront a question older than science itself. What if the laws we worship are not universal but local? What if the universe, vast and ancient, holds regions where reality itself runs by different rules? And if so, what had followed 3I Atlas into ours? By the time word of the anomaly reached every major observatory, the world's astronomers had turned their gaze toward a single point of sky. A network of lenses, mirrors, and instruments, Earth's collective eye now followed the faint ember of 3I Atlas as it drifted beyond Mars's orbit. Across continents and in orbit, humanity's instruments synchronized in purpose. They were not merely watching an interstellar rock, they were watching the universe break its own silence. The night above Mauna Kea shimmered with vapor and altitude frost when the Keck twin telescopes pivoted to track the traveler. Every few seconds, their massive mirrors adjusted, correcting for atmospheric distortion, each reflection capturing photons that had journeyed billions of kilometers only to vanish near the object. At the same time, the James Webb Space Telescope glided silently at L2, its sensors wide open, tuned to infrared wavelengths, tracing the soft hum of heat that even the coldest bodies emit. But the shadow gave off nothing. Webb's instruments saw the glow of the cosmos behind it, then nothing at all, a perfect silence carved into the spectrum. In Chile, under the cold clarity of the Atacama Plateau, the ALMA array turned its millimeter dishes skyward. Its engineers tuned the antennas to detect faint radio emissions that could betray gas, dust, or plasma, any sign of material explanation. The monitors flickered with static. There was no noise, not even the background whisper of the cosmic microwave radiation. The region behind 3I Atlas was less than empty, it was mute. ESA's Gaia Observatory, orbiting Earth with the precision of celestial cartography, tried triangulating the distortion using parallax. It failed. The readings returned contradictory distances, some placing the shadow closer than the object, some farther. In the data logs, one analyst typed the words that would echo through future discussions: "The universe cannot decide where the shadow is." Meanwhile, smaller ground observatories joined the Vigil Subaru in Japan, the Very Large Telescope in the Chilean desert, and the Vera C. Rubin Observatory, whose cameras scanned the sky with unmatched depth. All recorded the same eerie behavior. The darkness was moving in harmony with 3I Atlas, and yet its geometry seemed to respond to observation itself. When optical instruments focused on it, the shape constricted slightly. When observation paused, it relaxed, as though unobserved, it sighed back into its preferred form. Teams began layering data from different instruments, optical, infrared, X-ray, gravitational, to build a unified model. What emerged looked almost biological. The void wasn't static. It flexed, contracted, pulsed. Its margins trembled like a heartbeat of spacetime. "If we could hear it," one astrophysicist said softly, "it would sound like breathing." That sense of life unsettled even the most disciplined minds. Science is built on the assumption that nature, no matter how strange, remains indifferent. Yet here, the instrument suggested something that seemed aware, not conscious perhaps, but reactive, participatory. Quantum theory had long taught that observation alters the observed. But this felt as though the universe was leaning back to look at us in return. Data from NASA's Parker Solar Probe added another layer. Though far from the object's path, its magnetometers detected faint ripples in the heliospheric current, minute shifts that synchronized precisely with 3I Atlas's trajectory. Like the plucking of a cosmic string, the probe recorded oscillations propagating through the sun's magnetic field, as though the interstellar traveler and its shadow were vibrating the fabric of the solar wind itself. What disturbed scientists most wasn't the scale, but the elegance. Every data point fit a rhythm, something orchestrated, self-consistent, but foreign to known mechanics. The universe was performing an equation no human could solve. In an emergency session, the International Astronomical Union convened its advisory board to discuss the data integrity. Were the instruments malfunctioning? Could coordinated software errors across multiple continents produce identical artifacts? Unlikely. The consensus, reluctantly reached, was that the readings were real. Something large, coherent, and invisible was manipulating light and space across interplanetary distances. At the Jet Propulsion Laboratory, a smaller, more radical question arose. What if it wasn't moving at all? What if, instead, space around it was? The concept mirrored the mathematics of black hole frames, regions where spacetime itself rotated faster than light could escape. But the energy needed to produce such effects would exceed that of entire stars. For a faint, slow-moving object, such power was inconceivable. Unless the power didn't come from within, but from beneath, from the structure of spacetime itself. And so, telescopes kept watching. Weeks turned into months. The object continued its silent arc, and the shadow followed faithfully, as though tethered by a bond deeper than gravity. Observations began to reveal faint ripples around the void rings of distortion in background starlight that expanded outward, like echoes in a pond after a stone has sunk. The ripples were measurable, consistent, and inexplicable. By now, the phenomenon had entered popular imagination. Amateur astronomers tried to photograph the region. Conspiracy theorists spoke of alien craft cloaked in dark matter, and the press fed on the mystery. But within professional circles, conversation turned quiet. The data was too strange for declaration, too clean for denial. Those who knew the full scope of the readings didn't call it an object anymore. They called it the companion. Every night, in observatories scattered across the planet, people sat before screens, watching a speck of light and its shadow move together across the endless dark. The human eye, so used to finding patterns in stars, now gazed upon the pattern that refused to be seen. In the silence of a control room in Hawaii, an astronomer stared at the faint trace of the darkness and whispered to no one in particular, "It isn't passing through the light, it's teaching it to vanish." And around the world, those who listened felt the same unspoken thought. Perhaps the universe wasn't expanding into emptiness after all. Perhaps it was expanding into something that had been there all along waiting. By late autumn, the datasets from across the planet had coalesced into a portrait of paradox. The darkness behind 3 Atlas was no longer a blur of speculation. It had form, though that form refused all familiarity. The composite renderings produced by the European Southern Observatory revealed a pattern of distortions, arcs, rings, and lattice-like imprints, invisible in direct light, but traceable through their effects on distant stars. It was as though a crystalline structure, transparent to existence itself, was bending space-time in a rhythm too precise to be random. In one simulation, light rays entering the region didn't merely curve, they refracted. But there was nothing to refract through. The shadow acted like a lens without a medium, as if space itself had grown facets, polished by unseen geometry. The scientists called it the invisible lattice, though the name was an act of humility more than understanding. For all its ghostly beauty, it violated every known principle of optics. It was neither matter nor energy, yet it shaped both. From the James Webb Space Telescope came the next revelation. Its spectrometers, designed to read the elemental fingerprints of stars, planets, and galaxies, detected minute shifts in background wavelengths, tiny compressions and stretches that implied not gravitational influence, but something subtler, the periodic modulation of space-time density. Every few hours, the shadow pulsed, slightly tightening and releasing its grip on the surrounding void. The timing was exact down to fractions of a second, repeating with the mechanical precision of a heartbeat that belonged to the universe itself. Theorists began to divide into factions. One group proposed quantum coherence on a cosmic scale, a Bose-Einstein-like condensate of dark matter, so cold it transcended particle behavior. Another saw it as a boundary, a standing wave at the edge of overlapping dimensions. But the data contained hints of something stranger within the distortions. Faint interference patterns suggested information. Not randomness, but code. Lines of structured variation embedded within the void, as though the darkness were whispering in the language of light itself. No one dared claim intelligence. To do so would invite chaos. But late at night, when the models rendered their recursive spirals and fractal harmonies, Some couldn't help but wonder if they were looking at an artifact. Not alien in the cinematic sense, no ships, no beacons, but the residual architecture of something that once understood the fabric of the cosmos in ways we had not yet begun to imagine. In Switzerland, a team from CERN fed the data into their simulations of quantum vacuum fluctuations. What emerged was unsettling. The patterns matched predictions for virtual particle resonance in unstable vacuum states. In simple terms, the shadow behaved like the skin of the universe trembling near rupture, a place where energy might leak from one reality into another. "It's not just bending light," one physicist murmured, "it's bending being." Back on Earth, the Keck and Subaru observatories captured faint oscillations in polarization light that twisted as it passed near the shadow, as if its vector were being reoriented by invisible threads. The degree of rotation increased predictably with distance, a signature reminiscent of magnetic field interactions, but there was no magnetic source. The twisting was born of geometry alone. For months, astronomers catalogued these anomalies, each new observation deepening the riddle. The shadow wasn't a hole, nor a cloud, nor even a field in the traditional sense. It was structure without substance, a lattice woven of absence, tuned to the laws of some deeper, older physics. When visualized in simulation, the pattern resembled frozen waves, ripples of spacetime suspended mid-motion. Some frames suggested symmetry across 11 axes, evoking the mathematics of string theory's hidden dimensions. Others showed chaotic vortices that spun and then stilled, as though the darkness were experimenting with its own shape. And through all of this, 3I Atlas remained strangely unaffected. The rock tumbled forward in silent obedience, its path steady, its rotation constant. Whatever the shadow was, it didn't consume or alter the object it followed. It simply remained anchored, faithful, impossible. The relationship between the two defied explanation. Was the object the cause or the consequence? Was the lattice an echo of the object's interstellar past, or the reason for its journey? At the University of Cambridge, a meeting between theoretical physicists and cosmologists sought to reframe the mystery philosophically. Perhaps, they proposed, the darkness wasn't a thing at all, but a phenomenon, a visible manifestation of information transfer at cosmic scale. Just as a black hole hides its contents behind an event horizon, perhaps the universe itself hides communication within its structure. 3I Atlas might have simply wandered into one of those folds, a message written in gravity, now unfolding where we could finally see it. Meanwhile, instruments kept detecting faint, rhythmic changes in the cosmic background surrounding the shadow. The microwave afterglow of the Big Bang flickered near it, deviating from the expected uniformity. To some, this was proof that the lattice was feeding on the relic radiation of creation itself, a relic consuming relics. To others, it was the first sign that the structure connected eras as well as spaces. "It's as if time itself slows there," one cosmologist remarked. "As if we're glimpsing the memory of the universe, still forming." The final confirmation came from LIGO's gravitational wave data. A subtle resonance, impossible to attribute to any known source, matched the periodic pulses observed by Webb and ALMA. The frequencies aligned across light, gravity, and heat, the holy trinity of cosmic forces. The universe was singing one note, and the shadow was its instrument. In a debriefing at the European Space Agency, an elder astrophysicist summarized what all had come to feel. "We thought we were studying an object. But what if it's a mirror? What if the universe is showing us how it looks when it dreams?" The invisible lattice continued to glide beyond Mars's orbit, a perfect symmetry of nothingness tethered to a wandering stone. The instruments that tracked it were merely witnesses to something too vast to comprehend structure where there should be void, motion without force, a shape that was not there, and yet more present than anything that had ever existed. In that realization, a strange calm took hold among those who studied it. Because if the shadow was structure, if absence itself could possess form, then perhaps creation had never truly ended. Perhaps the act of forming still rippled outward, endlessly rewriting the cosmos, shaping new geometries from the vacuum of the old. And somewhere in that darkness, a secret waited, a secret not of destruction, but of design. They called them gravitational echoes, the faintest of murmurs, trembling through the silence of spacetime. It began when the Laser Interferometer Space Antenna, LISA, a collaborative mission between NASA and ESA, detected a sequence of oscillations that defied categorization. The signal didn't resemble the chirps of colliding black holes or the groaning symphony of neutron star mergers. It was delicate, repetitive, and hauntingly synchronized with the movement of 3A Atlas and its pursuing shadow. At first, the data seemed meaningless noise in the cosmic background, but as algorithms filtered through the static, a pattern emerged. Every time the interstellar object shifted orientation, every subtle change in trajectory, LISA's arms, millions of kilometers long, felt a whisper. A distortion in spacetime that arrived before the object's motion, not after. Cause and effect had reversed. The universe, it seemed, was hearing the movement before it happened. Physicists stared at the plots in disbelief. In Einstein's relativity, gravity propagates at the speed of light. There can be no advance warning, no echo of the future. Yet the readings showed a temporal inversion, a ripple preceding its source by seconds, sometimes minutes. The shadow behind 3I Atlas appeared to be broadcasting time in reverse. The phenomenon was named temporal lensing. Some speculated that the shadow acted as a space-time mirror, bending not just light, but chronology. Others whispered of something far stranger, that the shadow existed partially outside our temporal frame, slipping between moments as though time were a medium to swim through. In private conferences, the language grew philosophical. One physicist described it as the universe rehearsing its own events. What made this more unsettling was the alignment. The gravitational echoes came from a precise direction, one offset not by the object's current position, but by where it would be. The shadow was predicting its future location, and spacetime was responding as though anticipating its arrival. That discovery ignited a fever among theorists. Some saw it as evidence of a higher dimensional bridge, a wormhole not traversable by matter, but by gravity's own curvature. Others proposed that the shadow was the mouth of such a bridge, dragging 3I Atlas like a loose thread between universes. If true, the shadow wasn't chasing, it was pulling. It was homeward bound, returning the object to wherever it belonged. The equations required to model it nearly broke computers. Simulations ran into paradoxes, variables collapsing into negative infinities. The problem wasn't just computational, it was ontological. The shadow's effect on spacetime implied that somewhere, just beyond the reach of our perception, there existed another side, another frame of reference where time flowed differently, where the arrow of causality bent back upon itself. Some at CERN called it the mirror cosmos. In this hypothetical realm, gravity might repel instead of attract, entropy might reverse, and the fundamental constants of nature, speed, mass, energy could mirror their values inversely. The universe, they suggested, might not be alone. It might have a shadow of its own. And perhaps, through 3I Atlas, we had glimpsed the seam. When the James Webb Space Telescope reoriented its instruments to focus on the faint background behind the object, it recorded something that shouldn't have been there: faint gravitational shear-minute warping of distant starlight that didn't correspond to any known mass. The warping appeared behind the shadow, echoing its path like a wake following a ship. Yet the distortions were recursive, each echo spawning another, weaker one, spreading outward through spacetime like ripples in an endless pond. The pattern repeated in perfect mathematical intervals. It was a recursive harmonic, each echo exactly 1.618 times weaker than the last, the golden ratio, embedded in spacetime itself. A geometry of beauty and terror, written into the bones of the universe. Theorists couldn't agree whether it was coincidence or design. Some suggested natural resonance, a harmonic oscillation of spacetime responding to an unknown frequency. Others dared to wonder if it was communication, an encoded pulse sent through the medium of gravity itself. If so, it meant the shadow was not merely an effect of physics, but a participant in it, a presence expressing structure in the only universal language that existed, mathematics. And yet, behind the equations, the emotion of those who studied it began to change. Awe gave way to quiet reverence. Because for the first time in human history, we were not merely observing the universe, we were listening to it speak. The gravitational echoes continued for weeks. Every time 3I Atlas passed a threshold of distance or orientation, space-time trembled. The echoes came like a heartbeat, steady and patient. Even when the object drifted farther from the sun, the signal persisted, fainter but faithful. Astronomers began to notice that the rhythm of the echoes mirrored something else, the oscillations detected earlier in the cosmic background radiation. Across entirely different frequencies and epochs, the pattern held. The heartbeat of space-time, the lattice of invisible geometry, and the gravitational echoes were one and the same phenomenon, a chorus of the cosmos humming to its own reflection. When data from the Event Horizon telescope team arrived, it contained a single frame that silenced the room. Behind the faint smudge of 3I Atlas's light, there appeared a subtle ring, so faint it was almost invisible, an Einstein ring of distorted background starlight, forming a perfect circle not around the object, but around its shadow. And within that circle, nothing. The stars behind it disappeared completely. It wasn't lensing, it was omission. The shadow was not bending light, it was removing it from existence. That night, one scientist wrote in his private log, "It's not darkness we're seeing, it's subtraction, a place where the universe forgets itself." The phrase spread quietly, passed from one sleepless physicist to another, a place where the universe forgets itself. A haunting idea that perhaps this darkness was not new, not alien, but ancient. The cosmos may have always carried its mirror, unseen, the reflection of every star's death, every particle's disappearance, every light that had ever gone out. And now, in the fragile alignment of chance and observation, we had finally seen it. The gravitational echoes faded as 3I Atlas continued outward, but they left behind questions that trembled in every mind. Was the shadow a tear or a threshold? Was it showing us our reflection or something waiting beyond it? In the unblinking eye of the telescopes, it remained unchanging, silent, perfect, eternal, the echo of an echo, a soundless hymn across time itself. For months, the scientific community resisted the temptation to connect the phenomenon to the past. Yet as the data accumulated, one question became unavoidable: had we seen its shadow before? The answer, whispered through conference calls and encrypted channels, seemed to come from memory itself. Two names resurfaced: Oumuamua and Borisov, the first and second interstellar visitors. Both had crossed our solar system years before, fleeting guests from the cosmic deep. They had been dismissed as curiosities, rocks, or comets, unusual but not impossible. But now, in the light of 3I Atlas and its impossible companion, old data began to look like prophecy. In 2017, when Oumuamua swept through the inner solar system, it behaved like nothing known. Its trajectory was hyperbolic, unbound by the sunday. Its shape was unlike any comet or asteroid. Thin, elongated, tumbling erratically. And most unsettling of all, it accelerated as it left, not by thrust, nor by any detectable outgassing, but by an invisible pressure. Radiation pressure, some said, though the mathematics faltered. Light alone couldn't explain it. Oumuamua had moved, as if caught in a current that no one could see. Then came Borisov, in 2019, a true comet this time, its tail broad and chemical, familiar and reassuring. But even Borisov carried its unease, a spectral signature that didn't match any comet born from the sun's nursery. It carried carbon chains too ancient, too alien, like chemistry written before our own solar story began. When 3I Atlas appeared, few thought to link them, but in the wake of its shadow, archivists began to reprocess the old telemetry. Light curves, photometric data, faint gravitational distortions, each was reanalyzed with new algorithms trained on the 3I anomaly. And there, hidden in the noise, patterns began to emerge. In Oumuamua's outbound leg, telescopes in Hawaii and Chile had recorded slight irregularities in background starlight. At the time, these had been dismissed as calibration errors, atmospheric distortion, instrumental lag. But with fresh models, the distortions took form a faint dimming pattern, subtle and rhythmic, just like that of 3I Atlas. A shadow, smaller perhaps, but eerily similar in cadence. The discovery sent a tremor through the astrophysics community. Had we already encountered the same phenomenon twice before, blind to its presence? Was each interstellar visitor trailed by the same unseen darkness? To test the theory, the archival teams turned to Borisov. Its path, unlike Oumuamua's, had been thoroughly imaged across multiple wavelengths. And deep in the ultraviolet spectrum, they found it again, a faint suppression of flux behind the comet's trajectory, a shadow without depth, flickering like breath on glass. It was weaker, less defined, but consistent. 3 travelers, 3 shadows. The implications were unbearable. Perhaps all interstellar objects carried companions, ghosts, bound by laws beyond our reach. If so, the universe was not sending us random messengers, it was sending us echoes, each marked by the same signature of darkness. They are not objects, one theorist wrote in despair. They are apertures. The universe opens them, and for a moment, we see through. As the realization spread, new comparisons began. Across cosmic surveys, faint irregularities appeared in unexpected places: comets, rogue planets, even cold brown dwarfs wandering between stars. Many bore subtle light anomalies, tiny deficits where photons vanished into nothing. Could the shadow be a universal constant, a fundamental part of motion through interstellar voids? Some began calling it the Traveler's Veil. In a quiet symposium at the Max Planck Institute, a physicist named Ilara Fenning presented a chilling hypothesis. What if these interstellar visitors were not carrying shadows, but creating them, each passage through the gravitational boundary of a stellar system? She explained, could tear the quantum fabric of vacuum stability like dragging your hand through water. The shadow would be the turbulence, the vortex in space-time that remains. Her words hung heavy in the room. If true, it meant every interstellar arrival was not just a curiosity, but a wound, each one leaving behind a dark, persistent afterimage in the universe's light. But others went further. A quiet minority, led by cosmologist Dr. Ayad Holm from the University of Oslo, proposed a more disturbing thought. What if the shadow wasn't following these objects from outside, but waiting for them from within? According to his model, interstellar space was not empty, but layered a medium of invisible fields left over from the early universe, what he called primordial hollows. Objects passing through such regions could awaken dormant distortions in space-time, triggering temporary self-organization within the vacuum. The shadow, in this view, was not an alien entity but the universe's own memory of its creation, stirred awake by motion. He called it the echo of formation. In the silence that followed his presentation, few could decide whether that idea was beautiful or terrifying. As the 3I Atlas mission continued, comparisons to its predecessors revealed even subtler correlations. Oumuamua's acceleration pattern, when plotted logarithmically, matched almost perfectly with the harmonic ratios of 3 Atlas's shadow pulses. Borisov's ultraviolet suppression followed the same mathematical decay curve as the gravitational echoes recorded by LISA. 3 visitors, separated by years, linked by an invisible symmetry that spanned time itself. Suddenly, what had seemed isolated became a pattern, a cosmic rhythm playing across generations of observation. Each arrival might be a verse in an ancient song, sung in the dialect of physics, its melody written in the disappearance of light. In a darkened control room in Hawaii, a young astronomer whispered what many were beginning to fear. What if they aren't coming to us at all? What if they're returning? The idea spread like contagion. Perhaps the interstellar travelers were fragments of something vast and cyclical, echoes of a process that occurs when galaxies themselves breathe, when the universe expands and contracts. Maybe these were not messengers, but remains residual fragments of cosmic respiration, and the shadows, the memory of the breath. Still, science continued. Data was collected, refined, verified. The shadows were real, the pattern was real, but meaning remained elusive. Between the lines of observation, an unease settled, an ancient feeling not of discovery, but recognition. The cosmos, it seemed, was reminding us of something we had once known and forgotten, that even light carries its own darkness, and that between every journey there is something waiting, something that follows, not because it must, but because it remembers. Fear entered the mathematics first. It came not through hysteria or superstition, but through the quiet collapse of explanation. The data, when stripped of metaphor, demanded something impossible, a theory that could accommodate a moving absence, an entity that consumed light without energy, bent gravity without mass, and pulsed in harmony with time itself. Theories began to bloom like coral in darkness, each more desperate and beautiful than the last. The first contender was the quantum lensing hypothesis. It proposed that the shadow was a standing wave, a resonance in the quantum vacuum itself. According to this view, 3I Atlas had stumbled into a patch of spacetime so delicately tuned that virtual particles, the ephemeral ghosts flickering in and out of existence, had synchronized into coherence. Together, they formed a zone where the probability of light existing dropped to zero. The universe, momentarily uncertain of its own reality, refused to allow photons through. It was an elegant model, poetic even, but it collapsed under scrutiny. The quantum vacuum was too chaotic, too fleeting. To hold such structure across astronomical distances would require stabilization far beyond what natural processes could achieve. Unless, as some suggested, the shadow was a natural stabilizer, a self-organizing pattern of the vacuum, a kind of cosmic symmetry maintenance system. Not a creature, one physicist mused, but a correction. Then came the dark matter entity hypothesis. For decades, astronomers had hunted the invisible mass that shaped galaxies, the unseen hand whose gravity held stars in place. Yet dark matter had remained elusive, detectable only through its pull, never through direct observation. What if this was because, in rare conditions, it organized into coherent formations, structures that absorbed light, not by energy, but by topology, matter so cold, so alien, that photons simply ceased to exist within it? The shadow, in this model, was a dark matter bloom, a cluster of the unseen, alive only in geometry. But again, the numbers failed to obey. Dark matter did not interact with baryonic matter in this way. It did not follow, pulse, or echo. It simply was. The next theory emerged from the intersection of cosmology and terror, the vacuum decay model. It began with a nightmare that physicists had whispered for decades that our universe might not be in its true ground state. The vacuum that fills space, humming with invisible energy, might be a false stability. Somewhere, perhaps at the edge of the cosmos, the true vacuum might already exist, a lower energy reality expanding outward at the speed of light, rewriting the constants of nature as it goes. In this view, 3I Atlas was not carrying a companion, it was heralding one. The shadow, they said, could be the edge of such a bubble, the boundary between our decaying false vacuum and the encroaching real one, a place where light cannot exist because reality itself is shifting beneath it. If that were true, the universe was already doomed. But there was no fear in the equations, only inevitability. The speed of such a decay would be absolute faster than any signal, instant across spacetime. If it had begun, it would already have reached us, yet we still existed. The shadow's movement, then, disproved the apocalypse. It was not destruction, it was continuity. The void, somehow, lived. Others turned to more radical frontiers. The multiverse bridge hypothesis suggested that the shadow was a fold, a membrane through which gravitational information leaked from a parallel reality. In that neighboring universe, light might move differently, faster, slower, or not at all. What we saw as darkness could be illumination from the other side. 3I Atlas, then, was an interdimensional traveler, carrying with it a tether to its native cosmos, its own physics, leaking through like smoke through cracks. It was an intoxicating thought. Somewhere, another universe might be watching ours, and its light could be our darkness. A smaller, quieter faction proposed the conscious field theory. To them, the rhythmic pulses, the harmonic ratios, and the reactive behavior hinted at something deeper, not life as biology, but life as structure. Consciousness, they argued, could be fundamental to space-time itself, a property of geometry, not neurons. The shadow's reactions, its subtle contractions when observed, were reminiscent of awareness, not of thought, but of participation. Perhaps we're not observing the universe, said physicist Dr. Alina Voigt. Perhaps it's observing itself through us. Her words were dismissed by most too mystical, too human yet in private. Even skeptics wondered. The shadow seemed to respond not to energy, but to attention. By now, 3I Atlas had moved far beyond the orbit of Jupiter, its light dimming as the sun's reach faded. Yet the shadow remained visible in distortion, a moving ellipse of absence. Space agencies launched an unprecedented collaboration, directing radio telescopes, X-ray observatories, and deep space probes to coordinate observations. Among them, the New Horizons spacecraft, now drifting in the Kuiper Belt, was reactivated for one final mission to catch a glimpse of the object as it passed beyond Pluto's orbit. New Horizons instruments detected nothing directly, no reflection, no emission, but its star trackers recorded anomalies in position data, tiny fluctuations in navigation that suggested a gravitational irregularity passing between it and the distant stars. The measurements were too small for mass, yet too persistent for coincidence. It was as if the void itself carried weight negative, not positive, bending the ship's orientation subtly toward the absence. When this data reached Earth, the implications were staggering. The shadow wasn't simply a hole in light, it was a distortion in geometry. It possessed negative curvature, behaving like a region of space inverted against itself. Mathematically, it resembled the mouth of a traversable wormhole, though smaller, transient, unanchored. The theories converged into a single, terrible beauty. The shadow could be the footprint of a fundamental process, the universe folding itself inward, seeking equilibrium, whispering to itself through gravity's oldest language. Whether it was physics or consciousness, birth or decay, no one could yet say. In a moment of rare candor, a Nobel laureate, speaking off record, summarized the sentiment that haunted them all. It's as if the universe is dreaming, and this is the shadow of its eyelid. And so, scientists continued their work, equations like prayers, telescopes like eyes, searching for meaning in a cosmos that had begun to speak back. The theories multiplied, but one truth remained. The shadow was no illusion, no artifact of observation. It was real, and its presence whispered of something older than physics, something that predated even the laws we call natural. The shadow, whatever it was, seemed to know the universe better than we ever would. By the time the world's telescopes turned outward again in the cold months that followed, the focus of inquiry had shifted. The question was no longer what the shadow was, but what it revealed. Humanity had peered into a darkness that seemed to hold shape, a lattice of nothingness, sculpting light, pulling gravity, pulsing in rhythm with the universe's own breath. It was now impossible to deny that something vast and ancient was moving through the cosmic fabric, leaving faint fingerprints upon existence. The search for answers drove physicists back to the foundations of cosmology, to the invisible scaffolding upon which all galaxies rest: dark energy, dark matter, and the filaments that bind them. For decades, these had been mathematical ghosts, hypothetical threads, stitching together the structure of everything, unseen but inferred. Yet, as data from 3I Atlas deepened, an unsettling hypothesis began to emerge. Perhaps the shadow was not an intruder at all, but a window into that hidden framework, the skeleton of the universe itself. Across supercomputers in Geneva, Tokyo, and Pasadena, simulations of large-scale cosmic structure were overlaid with the distortion maps from the 3I Atlas field. The correlation was uncanny. The void trailing the object followed curvature patterns identical to those of cosmic filaments, those invisible veins through which galaxies align like dew along a spider's thread. It was as though the darkness had traced one of these ancient pathways, pulling a strand of the universe's architecture into view. This idea, radical yet hauntingly poetic, became known as the visible fracture hypothesis. According to it, the universe's hidden skeleton occasionally exposes itself when disturbed by motion through intergalactic space. 3I Atlas, crossing from one gravitational domain to another, may have brushed against the invisible lattice, its passage revealing the tension lines that hold existence together. The shadow would then be the scar visible only because reality momentarily remembered its construction. At the Max Planck Institute, cosmologist Anirudh Sen compared the phenomenon to the patterns formed on the surface of vibrating fluid, Chladni figures, he called them. Each star, each planet, each particle, he said, resonates along the lines of a greater frequency. What we see as galaxies are simply nodes of stability, frozen within the universe's own vibration. The shadow of 3I Atlas may be showing us that vibration made visible a fracture in the music. If the idea was right, then the universe was not a void sprinkled with islands of matter, but a living fabric of energy, its filaments singing silently across billions of light years. And within that living structure, dark energy flowed like blood, expanding the fabric itself. The shadow's pulsing rhythm, those faint periodic oscillations detected by Webb and LISA, fit perfectly with this model. It was as if we were watching the cosmic heart beating between the visible and the unseen. But even beauty carries fear, because if the shadow truly traced the skeleton of reality, then it implied fragility. Every lattice can fracture, every structure can fail. Some scientists began to whisper of topological defects, fault lines in spacetime itself. During the universe's birth, when everything expanded faster than light, imperfections could have formed in the cosmic field cracks left behind in the cooling structure of existence. These defects, invisible and ancient, might remain dormant for eons until stirred by motion or energy. 3I Atlas, hurtling through the intergalactic dark, could have struck one of those fractures, awakening it from dormancy. What we called a shadow could then be the result of space-time itself briefly unzipping, showing the hollow between dimensions, the place where the universe ends and begins again. In a white paper draft that never reached publication, two theorists from Caltech dared to propose an even darker vision. They suggested that the cosmic skeleton was not just the framework of matter, but of memory. Every event that ever occurred, every photon that ever traveled, left a faint imprint upon the fabric of reality. Over billions of years, these imprints overlapped, forming a multi-dimensional archive of existence itself. The shadow of 3I Atlas, they wrote, might be a visible section of that archive, a region where memory condensed so tightly that it bent space around it. It is not a shadow, they concluded, but the negative of time. If true, then the structure we saw was not a skeleton at all, but a library one whose shelves held the echoes of everything that had ever been. Meanwhile, astronomers noticed something else. The faint, rhythmic pulses of the darkness were beginning to drift, subtly changing their interval, lengthening like the slowing beat of a dying heart. The symmetry was breaking. Whatever the shadow had been, it was losing coherence, dispersing like smoke into the cosmic wind. Some rejoiced proof, perhaps, that it was only a transient anomaly, but others saw it differently. If the structure was part of the universe's foundation, its dissolution might signal more than the end of a passing mystery. It could be a symptom evidence that the underlying framework of space-time was weakening. To explore this possibility, the Euclid Space Telescope, newly commissioned to map dark energy, reoriented toward the region. It detected faint gravitational shear extending far beyond the visible edges of the anomaly threads, connecting distant clusters of galaxies, pulsing in harmony with the fading signal. 3I Atlas, it seemed, had not merely revealed the skeleton, it had awakened it. The entire region of space vibrated faintly in resonance, as though reality itself were humming, alive, and aware of being seen. Somewhere in those oscillations, scientists detected a strange alignment. The pulse frequency corresponded precisely to the average energy density of dark energy, the force driving the universe's accelerated expansion. This could not be coincidence. It was as if the darkness had drawn attention to the very heartbeat of creation, the pressure of nothingness that pushes galaxies apart. If dark energy was the engine of expansion, then perhaps the shadow was the smoke from its combustion, the mark of that endless outward breath. The cosmos, in that view, was not static but alive, inhaling and exhaling across eons, each expansion leaving fractures like ribs beneath the skin of space. 3I Atlas had simply brushed against one, revealing what was always there. In a late-night interview never broadcast, a NASA astrophysicist summed up the awe and dread that had begun to replace curiosity. We thought we were studying an anomaly in the sky, but what if we were studying the universe's reflection in a broken mirror? No one laughed. For all the elegance of their models, one truth pressed upon every mind the more we understood the shadow, the more it seemed that the universe itself was a living organism and that something within it was beginning to stir. It began with a whisper, a faint irregularity buried in the noise of the deep space network. At first, it seemed nothing unusual, a scatter of static, interference from solar wind or passing debris. But then the pattern repeated, a series of pulses, not random but rhythmic, each one perfectly timed with 3I Atlas's trajectory beyond the orbit of Jupiter. The signal came from multiple observatories at once. The Very Large Array in New Mexico, the Square Kilometre Array in South Africa, and the Parkes Observatory in Australia. Every dish turned its metallic face toward the same stretch of sky, and all heard the same thing, a faint, low-frequency resonance buried beneath cosmic noise. It was not sound, not in any ordinary sense, but modulation in radio flux, a whisper carried by the emptiness between worlds. The transmission was consistent, precise, unwavering. When plotted over time, it formed a pattern, 3 rising frequencies followed by silence, repeating every 37 minutes. The waveform itself seemed symmetrical mirror, imaged across its midpoint, as though it contained its own echo. No one dared say it aloud, not at first, but the implication was unshakable. Something was speaking. In a small conference at the Jet Propulsion Laboratory, data engineers cross-checked timestamps against every known astrophysical source. The signal did not align with pulsars, quasars, or background radiation. It matched only one thing, the motion of 3 I Atlas and its shadow. Each time the object adjusted its spin, the pattern shifted slightly, as though echoing its behavior. The discovery spread quietly through encrypted channels, then leaked to scientific forums. Speculation erupted. Was this a natural resonance, a byproduct of magnetic interaction between interstellar plasma and the object's field, or was it something deliberate, an encoded artifact embedded in the universe's hum? To eliminate the human tendency toward meaning, artificial intelligence was brought in. Programs designed for SETI analysis began parsing the data, searching for linguistic structure. What they found was neither language nor noise, but ratio-precise mathematical intervals between each pulse, recurring with the elegance of design. The pattern corresponded to the Fibonacci sequence, the same golden spiral that shapes galaxies, hurricanes, seashells, and perhaps even thought. Coincidence, perhaps, but as 3 I Atlas continued its journey outward, the pulse evolved. It began to drift downward in frequency, as though receding into distance or fading, like the breath of something ancient withdrawing from speech. Theories multiplied again. Some saw it as resonance between the shadow's structure and the cosmic microwave background, a form of standing wave communication between dimensions. Others proposed plasma, lensing a natural amplification of cosmic static sculpted by magnetic fields. But the synchronicity was too precise. The pattern's timing matched the gravitational echoes detected months before, and its harmonics mirrored the shadow's pulsation intervals. Across 3 different domains, light, gravity, and radio, the universe was repeating the same rhythm. A few dared to suggest the unthinkable that the signal was response. Weeks later, as the signal continued, the Voyager 2 probe, decades past its prime, sailing through the cold dark, recorded something strange. Its instruments picked up a fluctuation in cosmic ray density, precisely aligned with the radio pulse pattern. It was as though space itself vibrated with the rhythm, carrying it across unimaginable distances. When Voyager's data was processed and compared with ground-based readings, the correlation was perfect. Whatever was broadcasting, it was not local. It was everywhere. And yet, no transmitter could be found, no point of origin, no source. The signal came from every direction and none, emerging as if from the geometry of space itself. To some, this confirmed the resonant field hypothesis. The shadow was not an object, but a standing wave, a cavity where the universe's own frequencies reflected upon themselves. The radio pulses were not messages, but consequences, interference patterns between matter and its invisible counterpart. But others whispered of purpose. The Fibonacci ratios, the symmetrical echoes, they felt deliberate, intentional. A young astronomer at the Parkes Observatory unable to contain his awe, said during a live data review, "If this is natural, then nature is thinking." The words drew silence, but no one disagreed. As analysis deepened, something even more peculiar emerged. The intervals between signal bursts were lengthening, but not randomly. Each new interval corresponded precisely to the time delay between major historical bursts of cosmic radio background variation recorded over the last century. The signal seemed to mirror history itself, repeating the memory of the cosmos in rhythm with human observation. One physicist called it echoic resonance. "It's as if the universe remembers when we looked at it," she said, "and it's repeating the gaze." The radio telescopes, now operating in concert across continents, continued to listen. The pulses began to fragment, scattering into subharmonics that filled the spectrum from low-frequency radio up to microwave. Patterns formed nested fractals of signal density, like self-replicating signatures written in invisible ink. Each sequence contained ratios that, when graphed in 3 dimensions, produced spirals, lattices, and geometric forms eerily similar to the invisible structures already mapped around the shadow. It was as though the universe had begun to draw its own skeleton. Then came the silence. Without warning, the signal ceased. The last pulse arrived at 0211 UTC on a cold January morning, and then there was nothing. No echo, no residue, no static. The cosmos returned to its ancient stillness. In the absence of noise, an almost religious unease took hold. The scientists who had been monitoring the transmissions spoke little. The instruments continued to record emptiness. For the first time, the silence felt alive, pregnant with awareness, as though something immense had exhaled. Weeks later, a final anomaly appeared. The Deep Space Network caught a faint reflection of the last pulse, delayed by exactly 11 hours and 56 minutes the rotational period of Jupiter. It was as though the signal had looped around the giant planet, reflected back by its magnetic field, and whispered its farewell to Earth. This reflection carried no pattern, no Fibonacci symmetry, only one simple amplitude rise, a single heartbeat against infinity. To many, it felt like closure. To others, it felt like the end of a conversation we had never known we were having. When the data was finally archived, one scientist wrote in the summary log, "We listened, and the universe replied. It told us nothing but in its silence. It left a question that will outlive us all." And somewhere, billions of kilometers beyond the reach of sunlight, 3I Atlas drifted on, trailed by its fading shadow. Behind it, the stars returned to their normal brightness, as though nothing had ever happened. But the world's radios, those that knew where to listen, still hummed faintly with the ghost of a rhythm. 3 pulses, silence, 3 more, and every time, the space between them felt a little longer, as if the cosmos itself were pausing to remember. Mathematics, in the end, became the only language left that could still approach the impossible. As the shadow of 3I Atlas slipped farther into the outer reaches of the solar system, attention turned inward to blackboards, to notebooks, to the pages of physics itself. The data had grown cold, but the equations were alive. If the universe was speaking through rhythm and silence, then its syntax must be written in form, in the language of spacetime. The first to suggest a coherent model was Dr. Elise Navarro, a theoretical physicist at the Perimeter Institute. She described the phenomenon not as matter nor energy, but as an inverse wave, a field whose amplitude carried negative energy density. In her model, the shadow's behavior could be described by an equation resembling Einstein's general relativity, except inverted. Where spacetime usually curves toward mass, the equations curved away from it. In essence, the shadow was an anti-gravity wave space that repelled itself. What stunned her colleagues was what followed. This negative curvature predicted motion, not forward, but backward, through time. In Navarro's calculations, the shadow didn't chase 3I Atlas. It preceded it, moving in reverse temporal flow. The shadow, she wrote, might not be following the object, it might be its origin, the echo that existed before the event it caused. Her paper, circulated privately, sent ripples through the scientific community. If true, she noted in her closing lines, then cause and effect are not linear, they are a Mobius strip. Every object is the echo of its own future. It was an intoxicating notion. The universe, looping within itself, might project effects backward, creating a cascade of causality we perceive as time. The shadow, then, was not a pursuer, but a mirror of the object's own future state, a reflection from the other side of temporality. At CERN, a different approach emerged. Physicists there began modeling the shadow as a tachyonic field, a wave of imaginary mass propagating faster than light, traveling from future to past. In the quantum vacuum, tachyonic interactions were theoretical phantoms unstable, forbidden by conventional relativity. But the math fit too perfectly to ignore. Simulations of tachyonic resonance recreated the gravitational echoes recorded by LISA and the radio pulses captured by Earth's observatories. The oscillations matched precisely, down to their recursive ratios. When plotted in four-dimensional Minkowski space, the shadow's path traced a spiral, not through ordinary space, but through spacetime itself, weaving between timelines like a thread pulled through cloth. It was as though the shadow wasn't moving through the universe, but between its versions. The discovery forced a philosophical crisis. If the shadow was indeed a negative energy wave traveling backward through time, then everything we observed was already written. Every photon, every echo, every anomaly had already happened long ago in the universe's future. Observation, in this sense, was not discovery, but memory. The cosmos was remembering itself through us. Dr. Hideo Kuroda of Kyoto University went further still. He proposed that the shadow represented an entropy inversion, a local region where time's arrow bent inward. Within it, the second law of thermodynamics reversed, order increased, information condensed. To an external observer, such a region would appear dark, for light itself, an entropic agent, could not survive the reversal. In his equations, the shadow wasn't destruction, but condensation, a well of increasing structure, a point where reality became more organized rather than less. When combined with Navarro's model, the implications became staggering. The shadow could be a temporal seed, an origin point for universes to come. The interstellar object might simply be the visible tether of a process far larger than itself, the self-writing mechanism of creation. One late-night session at CERN's theory group gave birth to what they half-jokingly called the God equation. By merging the field equations of relativity with negative energy tensors, they produced a model in which spacetime itself oscillated between positive and negative curvature, expansion and contraction, existence and negation. The oscillation's frequency, when scaled cosmologically, matched the observed rate of dark energy expansion. The universe, they concluded, could be an interference pattern between two realities moving in opposite temporal directions. Where they met, phenomena like 3I Atlas's shadow would appear moments where the two flows of time briefly touched, creating ripples of impossible symmetry. In a paper published only months later, Navarro's team phrased it differently. "We are the standing wave between two eternities." The phrase caught fire among scientists and poets alike. Suddenly, the cosmos seemed not vast and indifferent, but intimate, folded inward upon itself, its laws humming in quiet recursion. The equations didn't merely describe a physical process. They suggested a deeper identity, The universe was not expanding into emptiness, it was expanding into itself. To test the theory, the European Space Agency began preparing for an experiment so delicate it bordered on metaphysics. They called it Project Helios. Its goal was to detect the temporal reflection of 3I Atlas's path, a hypothetical trace of the object before it entered our solar system. If the shadow truly traveled backward in time, there should exist faint imprints of its presence years, perhaps centuries, prior to its arrival. Radio archives, cosmic background surveys, and even historical astronomical records were scoured. And in the grainy plates of 19th century sky photography, they found anomalies, tiny voids in the star fields, circular dimmings consistent with the modern signature of the shadow. It had been here before, or rather, it would always be here. The realization shook the foundations of philosophy and science alike. If time folded upon itself, then observation and causation were not separate, they were simultaneous. Every act of perception was both past and future, intertwined in an eternal recursion of awareness. For some, it was liberation, for others, despair. If the shadow was the universe remembering itself, then perhaps consciousness, our fragile spark of awareness, was part of that same reflection. The mind, too, might be a negative wave, echoing backward through the vastness, remembering what has not yet occurred. When asked what it meant, Navarro's final remark, before retreating from public life, was simple and devastating. The shadow is not chasing 3I Atlas, it's chasing us. In the years that followed, the mathematics continued to refine itself, elegant and terrifying in equal measure. The shadow's equations found new homes in cosmological models, particle physics, and even neuroscience. Every field that studied the nature of information began to feel the same quiet pull, that perhaps, beneath all complexity, the universe was not a place at all, but a conversation between what was and what will be. And through that conversation, silence had spoken first. When the mind could no longer explain, it built tools instead. Machines became our questions given shape. Humanity turned its ingenuity toward the darkness, desperate to test whether the shadow's enigma was a truth of physics or a trick of perception. Instruments of unprecedented precision were born from the confusion, a quiet arms race of curiosity against the cosmos itself. The first to awaken was LISA, the Laser Interferometer Space Antenna. Floating in a triangle of satellites millions of kilometers apart, it listened for the faintest ripples in spacetime. Its detectors, more sensitive than any ear ever built, caught the murmur of gravitational harmonics still echoing from 3I Atlas. But they were changing, becoming irregular, evolving. The oscillations that once pulsed like the rhythm of a metronome now fluctuated, as though a dialogue were underway and the shadow had altered its tone. Across the ocean, the James Webb Space Telescope turned again, though its lenses were now pointed toward the shadow's wake rather than the object itself. The infrared light there flickered unnaturally, an aurora of invisible energy where no radiation should exist. Photons arriving from behind the shadow showed subtle phase shifts, as if they had traversed regions of time stretched thin. Webb's engineers struggled to describe it. The official language spoke of temporal interference. In less formal terms, one of them whispered, "It's like the light has traveled through a memory." Meanwhile, on Earth, CERN reopened experiments that had lain dormant for years. In the tunnels beneath Geneva, colliders were recalibrated to search for the signature of negative energy states predicted by Navarro's and Kuroda's equations. When particles collided at near light speed, brief voids of measurable absence appeared, microseconds of missing energy, as if the collisions had borrowed mass from somewhere outside our frame of existence. For the first time, mathematics and observation nodded to each other in uneasy agreement. But the shadow remained distant, sliding silently toward the heliopause, the edge of the sun's influence. To chase it, humanity turned its eyes from telescopes to ships. The Helios array was launched in 2031, a coordinated network of solar probes armed with interferometric sensors and quantum entanglement relays. Each unit carried photon pairs split and mirrored, one particle staying near Earth while its twin was sent outward, beyond Pluto's orbit. The theory was elegant. If the shadow distorted spacetime's fabric, the entangled partners would decohere, changing their spin alignment even across billions of kilometers. Months passed. Then, quietly, the data arrived. Decoherence was real. The spin of Earth-bound photons began to fluctuate in perfect synchronization with 3I Atlas's trajectory. The phenomenon persisted, repeating each time the shadow shifted phase. It was as if reality itself trembled when the darkness moved. The Large Synoptic Survey Telescope, now called the Vera Rubin Observatory, joined the hunt, capturing optical distortions invisible to the human eye. Its high-speed cameras revealed faint ripples sweeping across background galaxies in perfect unison with the gravitational echoes from LISA. The ripples resembled waves on water after a distant disturbance, a tidal pulse of geometry. The stars were shimmering, not from heat or distance, but from space-time itself breathing. At the European Space Agency, researchers pushed for one final leap. They designed Erebus, a probe named for the Greek god of primordial darkness. Its mission to pursue the shadow directly. Erebus would leave the solar system under nuclear sail, its trajectory matched to intercept the path of 3I Atlas years after the object itself had vanished into the interstellar gulf. As Erebus prepared for launch, physicists debated what they would even look for. The shadow had no matter, no radiation, no conventional signature. "We are sending a question," said Project Director Soraya Najam, "and hoping the universe answers." Months before departure, a final calibration test revealed something eerie. When Erebus's onboard laser interferometer was powered up, it detected faint vibrations, tiny periodic shifts in beam coherence, identical to those recorded years earlier by LISA. The signal was not coming from the stars. It was inside the probe, resonating in the equipment itself. Somehow, even before leaving Earth, Erebus was already hearing the shadow. After launch, communication delays grew with distance, but the probe's telemetry painted a haunting picture. Beyond the orbit of Neptune, instruments recorded faint fluctuations in the cosmic background temperature. Each fluctuation matched the rhythmic pattern of the now faded radio pulses that had once echoed through Earth's telescopes. The pattern had returned. LISA confirmed it within hours. The gravitational harmonics were back, faint but persistent, and aligned with Erebus's position. Whatever the shadow was, it had noticed. Meanwhile, deep underground, quantum physicists at the Kavli Institute built an array to detect hypothetical temporal gravitons particles that might carry information across the arrow of time. The detectors ran in complete isolation, sealed from light, sound, and human interference. For months, they recorded nothing but silence. Then, one evening, as Erebus crossed the heliopause, the instruments flickered to life. They emitted a pulse, faint and cold, with no known origin. The timing was exact down to the millisecond. At that moment, across hundreds of astronomical units, the probe's sensors also spiked. It had entered a region of gravitational flux, so delicate it resembled breathing an invisible tide oscillating through the vacuum. Erebus's cameras saw nothing but stars, yet its instruments screamed with data fluctuations in dark current, sudden distortions in onboard atomic clocks, and, faintly, the echo of a single rhythmic pulse. It was not a roar, not a beacon, but a heartbeat slow, immense, unending. As transmissions streamed back, a new realization dawned among those who studied the data: the universe was not still. It quivered, infinitesimally but perpetually, like the surface of a lake struck by invisible wind. Every star, every particle, every mind existed upon that trembling surface. Erebus continued its course, vanishing into the interstellar dark. The final signal it transmitted was a spectral sweep of pure amplitude. When translated into audible sound, it became a low, steady tone, a single note that seemed to hover between harmony and sorrow. Scientists replayed it in laboratories, in lecture halls, in dark rooms late at night. The tone carried neither pattern nor message, yet to those who listened long enough, it felt like recognition. "It's not noise," said one of the analysts quietly. "It's acknowledgement." And for the first time, humanity began to understand that its search for understanding might have been noticed not by gods, not by beings, but by the fabric of existence itself. The machines had spoken. They had measured something that should not be measurable: the pulse of the void. And though data continued, though instruments hummed and telescopes turned, a quiet consensus spread among those who had seen the numbers. No discovery would ever again feel like victory. Because behind every equation, every detection, every flicker of light, they now sensed the presence of something watching back, a listener, older than time, patient and awake. By the time Erebus vanished into the silence beyond the sun's domain, humankind was left with fragments, measurements, harmonics, and a feeling that science had brushed against something it could name but never comprehend. Yet the deeper the data was studied, the more the conversation turned inward. Equations gave way to metaphors. The physicists, stripped of certainty, began to sound like poets. At the International Symposium on Cosmology in Geneva, a new theme took hold: not what the shadow is, but what it means. If Navarro's inverted spacetime model was true, then the shadow was the reflection of time itself, an echo moving backward, erasing light as it went. If Kuroda's entropy inversion was correct, then it was creation turned inward, the seed of universes unborn. But for philosophers, it was something older and quieter, a mirror held up to humanity's need to know. Dr. Ida Holm, a cosmologist turned phenomenologist, spoke softly to a hall of scientists who had long stopped pretending to understand their own discoveries. "We have spent centuries turning the universe into a mirror for our minds. But what if this impossible darkness is the mirror turning back toward us?" Her words lingered. In that silence, a strange humility settled over the scientific world. Perhaps the shadow had no message. Perhaps its purpose was to remind us that even now, after millennia of thought and light, there are still places where reality folds away from comprehension, and that those places are sacred. Philosophers began to gather the fragments of physics into a new language. Some called the shadow a geometric consciousness, the universe reflecting upon itself through the act of observation. Others described it as the first physical evidence of awareness embedded in space-time, a phenomenon not of biology, but of being. The idea was not new. Ancient mystics had spoken of the cosmos as a living whole, every star a cell in its vast body. Now, after centuries of dismissing such visions, science found itself circling back not to superstition, but to awe. "The shadow," wrote one researcher, "behaves as if the universe is looking at itself through us and forgetting nothing." Across the world, people watched reprocessed images of 3-eye Atlas grainy frames of a faint traveler and its invisible companion. The footage, stitched together into documentaries and shared across networks, carried the stillness of revelation. There were no bright explosions, no alien signals, just an endless drift through the quiet, dark, followed by a moving absence. And yet, millions watched in silence, feeling something ancient stir behind their ribs. At the Vatican Observatory, theologians met with cosmologists. At CERN, physicists invited monks. In Japan, Buddhist scholars wrote essays comparing the shadow to the concept of mu, the emptiness that gives rise to all form. Perhaps, one wrote, the universe needed to remember its own silence, and so it created one. The scientific establishment, once wary of poetry, began to accept it as the only adequate response. Equations could describe curvature, but not wonder. Data could record absence, but not meaning. For the first time since Galileo, science looked not outward, but inward, and found the same mystery waiting in both directions. Public fascination turned reverent. The shadow's story became the most watched cosmic event in human history. Artists painted it as a veil of glass between worlds. Composers translated its gravitational frequencies into low, resonant symphonies that felt like the breathing of creation itself. Writers called it the night that moves. Children learned its rhythm in classrooms, clapping 3 times and pausing, repeating the silent pattern the cosmos had whispered back. In universities, the line between physics and metaphysics blurred. Young theorists argued that the boundary between observer and observed was dissolving. If the universe reflected itself through our instruments, then humanity was not separate from its mysteries, but part of their unfolding. One essay called it the participatory cosmos, the idea that the act of wondering is itself a physical force, that thought bends reality as gravity does. And yet, beneath the poetry, a shadow of another kind remained. The negative energy models implied instability. If the shadow truly represented a crack in spacetime, it could spread an infection of order in a universe that depends on chaos. A few quiet papers warned that too much observation might feed it, strengthen it, give it permanence. If consciousness is part of the equation, one theorist wrote, then perhaps we have already entered the experiment we meant only to watch. Still, most found peace in the idea that knowledge, even incomplete, could be beautiful. The darkness had not destroyed us. It had not devoured light, nor collapsed the heavens. It had simply been as eternal and indifferent as a mountain, as intimate as breath. In her last interview, before vanishing into retreat, Dr. Navarro said, almost tenderly, "Perhaps the universe only becomes real when we look at it. And perhaps what we saw the shadow was it looking back, asking the same question." By then, 3I Atlas and its companion were gone beyond detection. No telescope could find them, no radar could chase their path. Only the ripple of their passage remained a faint distortion in the cosmic microwave background, a heartbeat at the edge of measurement. And yet, in the quiet observatories of Earth, astronomers sometimes reported a familiar flicker in their data, a brief dimming, a pulse in the deep-field stars, a breath in the silence. They would glance at each other, say nothing, and continue working. Because maybe the shadow had never left. Maybe it had simply turned invisible again, folded back into the structure of reality, waiting for the next question, the next mind brave enough to notice that even light casts a darkness of its own. And so, the study continued, not in pursuit of certainty, but in reverence for the unanswerable. By the time the last traces of 3I Atlas faded from the telemetry of human instruments, its shadow had already become myth. In data, it was an enigma, in thought, a mirror. The stars went on shining, but they no longer felt the same. Every telescope, every satellite, every mind that once stared outward now carried the quiet knowledge that the universe was not a void, it was a gaze returned. In observatories around the world, the consoles still glowed, the monitors still pulsed, though most of the readings now showed nothing but ordinary cosmic background. The extraordinary had slipped away, vanishing into the deep. Yet in that absence, something vast had changed. The silence left behind was not emptiness. It was presence, a waiting, listening kind of quiet. At Mauna Kea, where the story began, a group of astronomers gathered one last time to mark the disappearance. Outside, the volcanic summit lay under a sheet of snow, clouds drifting below the dome like oceans of vapor. Inside, the room hummed with soft electronics and human stillness. They stared at the final transmission from Erebus, a scatter of photons faint beyond recovery. Somewhere within those final pixels was the echo of the shadow's last pulse, a rhythm now lost to entropy. They watched the numbers dissolve into static. For a moment, no one spoke. Then one of them whispered, "It's gone." And yet, none of them truly believed it. Because when they looked again at the static, the graphs, the nothing, they felt the same hush that follows revelation, the sensation not of loss, but of completion. Perhaps the shadow had not ended. Perhaps it had simply returned to the invisible places it came, from the thin seams where time folds inward and memory becomes matter. Perhaps it had never been out there at all, but within the structure of being itself, surfacing only when the cosmos wished to remember. On Earth, the story of the shadow rippled outward like gravity. In classrooms, children traced the path of 3I Atlas on maps of the solar system, learning that science was not just the search for answers, but the courage to face questions that have none. Artists painted its passage as a wound of gold through the night sky. Musicians turned its oscillations into sound, the low thrum of gravitational harmony played in concert halls to audiences who wept without knowing why. In philosophy, it changed the meaning of discovery. No longer a conquest of ignorance, but a conversation with it. Scientists began to speak of the listening universe, where observation was not domination but communion. The great observatories of the world rewrote their charters not to measure the unknown, but to witness it. Even religion shifted, subtly. In temples and mosques and cathedrals, the ancient word for mystery, once divine, now scientific, returned with new resonance. The cosmos was not cold, it was not hostile, it was not even silent. It was a being of its own kind, older than time, vast beyond reason, capable of forgetting and remembering itself through the minds that dared to ask what it was. And yet, for all the wonder, a quiet unease persisted among those who had seen the original data. For them, the shadow was not a metaphor, not a symbol. It was a measurement, a structure, a fact, a part of reality that did not belong yet, insisted on being known. What if it had not departed? What if its disappearance was simply a shift in perspective, like turning a prism so the color changes, but the light remains the same? Some whispered that the gravitational echoes still trembled faintly in the noise, too subtle for instruments to isolate. Others claimed that the cosmic microwave background itself had altered since the encounter, its symmetry slightly skewed, its wavelengths whispering of interference from something unseen. But these murmurs faded into the white noise of human speculation, as all great mysteries do. And in that fading, something sacred took root. Because in the end, the shadow's greatest revelation was not cosmological, it was existential. It taught us that even in an infinite universe, there are boundaries that light cannot cross, not because they are closed, but because they are still opening. It taught us that every question we ask is itself an act of creation, shaping the fabric that answers back. And it reminded us that we, too, are travelers between darkness and light, our thoughts casting shadows that outlive their source. The universe, it seemed, had always been whispering. We had finally learned to listen. The night sky remains what it has always been, immense, patient, and wild. The stars still sing their ancient harmonies. The blackness between them still breathes its quiet depth. Yet somewhere, far beyond the reach of radio or reason, something continues to move, a traveler of stone, trailed by a companion that is not matter, not energy, but the shape of what cannot be understood. They glide together through the endless night, one seen, one unseen, like a thought and its memory, a light and its absence. And perhaps, in their passage, they leave behind not answers, but invitations, reminders that to know the universe is to share in its dreaming. And now, as all instruments fall silent and the hum of data becomes only static, the universe returns to its original tempo, a slow breath, a quiet rhythm in the dark. The story of 3I Atlas and the shadow that should not have been fades like starlight beneath the horizon of time. Yet the echo of its mystery remains, suspended in the human mind, where curiosity and wonder still burn like the faintest sun. Perhaps, someday, another traveler will come, another wanderer from the depths between galaxies, and with it, another uninvited darkness. And when it does, we will be ready, not with certainty, but with reverence, because we have learned that some mysteries do not exist to be solved. They exist to remind us that the universe, vast as it is, has room for the impossible. So we look upward again, toward the ancient sky. The stars whisper their old stories, the galaxies drift like thought, and in the stillness between, we hear it a pulse, faint but eternal, the shadow's rhythm still echoing across the fabric of everything. The cosmos turns infinite and serene. Somewhere, beyond the reach of time, the light continues to move, and behind it, its darkness follows, not in pursuit, but in partnership. One defines the other. One cannot be without its reflection. And so the story closes, as all cosmic stories do, not with finality, but with continuation. The question remains, shining in the void, waiting for us to ask it again. Sweet dreams.